Let me throw out a couple examples where customers can use some of the privacy preserving computation techniques. For example, imagine that we've got a bunch of DNA data that we've collected from patients and so forth. Of course, this information is protected by HIPAA, but let's say we wanted to do some research on a large set of DNA, but we didn't want to violate the HIPAA restrictions on sharing that data. And let's say that you have a healthcare organization, I've got a healthcare organization, and there are three other healthcare organizations that we might not necessarily trust, certainly not enough for us to share data. So let's say that all of us encrypt our DNA data. We all send it into a centralized server. Now, I take my key, which is Saskatchewan, and I unlock it, and lo and behold, I have an answer in there that is the average of the DNA data that I had sent in with an unknown number of other data points. Because I sent in encrypted data and it was never decrypted, that means that I have adhered to all of the HIPAA laws. And so all of the compliance regulations, we can do multi-party computations without ever divulging what that data is. Now, that's got some really big ramifications, certainly for collaborative computation, but also for how to protect and keep data in use, especially when it's protected by regulations.
So one thing that I love about that example, Mark, is that the whole original purpose of the internet was to allow for collaboration. And many of the advances that have been exciting and useful were designed to support, multi-site collaboration. Are we going to see companies that specialize in this kind of thing making a service offering to allow us to leverage these techniques for the most critical parts of our data?
I think you nailed it. Like on-demand services, I mentioned our little DNA example. There are a couple of cloud services that have just come on board. Probably the most talked about is by IBM, but certainly there are other companies that are offering homomorphic encryption as a service now. I think we're going to see homomorphic encryption on a chip come out quite soon. I think that end-to-end security systems that have not just homomorphic encryption, but other privacy preserving computation techniques embedded in them are going to come out for an end-to-end complete security system, all the way, as we talked before, from data at rest, data in transit, all the way to data in use. But I think an interesting ramification is if these techniques can be used with very little overhead, we're talking dozens of percentage points of overhead as opposed to millions of times overhead. It does pose the question, wouldn't we just have encryption by default? That all of our data stores, all of our databases would just encrypt data this way, and that would be the default. And you'd have to have a very good reason why you would store data in the clear. Now, that's a huge paradigm shift, not just for data, but for data storage systems, for infrastructure, for cloud computing, for networking. The idea that all data would always be encrypted is quite a fascinating horizon that I think we're quickly approaching.
Well, Mark, I really think this is a fantastic topic, and I appreciate you illuminating some of this stuff for me today on Technically Speaking.